Hi, I'm Chris. This is Computing with Chris. Today we're going to talk about the edit distance problem, which is the problem of finding the minimum number of edits to transform one sequence of letters into another, where edits are inserting a letter, deleting a letter, or replacing a letter. So for example, we could ask, what's the minimum edit distance between covfefe and coverage? So what are the minimum number of insertions, deletions, or replacements of letters that we would need to transform one into the other? Well, let's see. So I'm going to write out covfefe with some more spacing. And so we could delete the F, so that's 1. We could replace this F with an R, that's 2. And then we could insert an A and a G here, that's 2 more. And now we have coverage. So the edit distance is 4. Edit distance is used, for example, in spell correction, like if you have fat thumbs when you're typing on your phone keyboard. It's also used in computational biology to assemble fragments of sequenced DNA to help understand the evolutionary tree of life and to compare individuals and identify mutations. In this video, we're going to look at edit distance on DNA sequences, which have nucleotide letters A, C, G, and T. And we're going to use the notation D being the edit distance function. So for example, D of A, G, T to G, C, G, T. So this means what are the minimum number of insertions, deletions, and changes of letters to go from AGT to GCGT. And it also gives you the same answer if you ask going from GCGT to AGT. And you can do an exercise at home to convince yourself that that's the case. So let's figure out what this would be. So we can start with AGT. And there are a couple of ways to do this. So one would be to remove the A, so that's one change. And then insert a C and a G in here. So that's 3 total, right? Another way we could do it though is we could transform the A into a C, so that's 1, and then we could add a G here, so that's 2. So the minimum edit distance is this one, 2. As a computer scientist, when I see a hard problem, I look for easy problems lurking inside. So for edit distance, certainly some instances of the edit distance problem are easy or even trivial. In fact, Warm Biking Gloves Chris has worked this out. Can you show us? If one of the sequences has length 0, then the edit distance is just the length of the other sequence. Very impressive. Obviously, if the letter sequences I'm working with both have more than 0 letters, it's going to be a lot harder. But I'd still be in good shape if I had the good fortune to know the edit distance of the slightly shorter sequences of letters that are embedded within my long sequence. Now, admittedly, this part's kind of tricky, but Pink Gloves Chris has worked out how to do it. If the first letter of the 2 sequences matches, then the distance between the sequences is the same as the distance between all but the first letter of the first sequence, like CTG in this example, and all but the first letter of the second sequence, so TGAG in this example. On the other hand, if the first letter of the first sequence is different from the first letter of the second sequence, then I've got to look at a few different options. So one option for transforming this sequence into this sequence would be to first insert a C in front of this sequence, and then transform all of these letters, A, C, T, G, into all of the letters here after the C, so T, G, A, G. And if I did that, I would have one change to insert the C, and then I would have however many changes it takes to transform A, C, T, G into T, G, A, G. So I would have 1 plus the distance between ACTG and TGAG. So that's one option. A second option would be to delete the A from here and then transform CTG into this whole thing, CTGAG. So then I would have 1 for deleting that A plus whatever the distance is between CTG and CTGAG. And the final option would be to change the A into a C and then use whatever distance is between CTG and TGAG, right? So overall, the distance between this sequence and this sequence is 1 for whatever transformation I decide to make, plus the minimum of whichever of these is the smallest. And that's going to give me overall the minimum distance to transform ACTG into CTGAG. It doesn't seem like we've made much progress, but in fact, we now have everything we need to solve arbitrary edit distance problems. Let's see how this works.